China's People's Liberation Army Air Force recently unveiled the first high-quality images of the j-11D fourth-generation air superiority fighter, the latest derivative of the Soviet Su-27 flanker design, and the fifth to be manufactured in China. Flanker derivatives have come to form the bulk of the PLA Air Force's combat fleet since their acquisition from Russia in 1992, with over 500 currently in service, including both Russian and indigenous variants. The j-11D program and recent acquisitions of both the Russian Su-35 and indigenous J-16 strike fighter demonstrate that the PLA sees a continuing role for enhanced flanker derivatives as it modernizes its aerial warfare capabilities. The new fighter represents the latest of China's new generation of indigenous fighters, alongside the Chengdu J-20 stealth platform, which entered service in March 2017, and the J-10C, which was inducted in April the following year and is capable of fulfilling a highly complementary role to these two aircraft. The fighter is a direct analog to the Russian Su-35, of which the PLA has received 24 since 2016, and is speculated to have benefited considerably from a study of Russia's own enhanced flanker design. China has manufactured enhanced derivatives of the Su-27 since the mid-1990s, when the Shenyang Aerospace Corporation began to mass-produce the j-11B fourth-generation air superiority fighter as an enhancement of the original Su-27 acquired from Russia. While the airframe of this platform was almost identical to that of the original Su-27, avionics, sensors and electronic warfare systems were all indigenous, and later production batches also integrated indigenous WS-10A turbofan engines in place of the Russian Al-31F. While Chengdu has already completed development of the J-20 as a fifth-generation air superiority fighter, the first aircraft of its generation developed anywhere in the world outside the United States, the PLA still has much use for high-end fourth-generation aircraft, which, though lacking the J-20's stealth capabilities and its next-generation WS-15 engines, are able to compensate for this in other fields. Although the J-20 program does not face the constraints of its US and Russian analogs, with production of the former's F-22 Raptor terminated due largely to massive operational costs, while the latter's Su-57 program has floundered due to a lack of funding, the PLA is still unlikely to rely on high-end stealth jets to make up its entire air superiority fleet. Although estimates of the J-20's acquisition costs remain modest by the standards of fifth-generation aircraft, the j-11D is likely to be considerably cheaper to operate and easier to maintain, while its airframe will be able to more easily integrate a wider range of technologies, including three-dimensional thrust vectoring engines and next-generation missiles, such as the ship-hunting IJ-12 and ramjet-powered PL-21 AWACS Hunter, which are not compatible with the J-20. The fact that the J-11D carries its weapons externally gives it access to a far wider range of munitions than the J-20, which is limited by the dimensions of its internal weapons base. With comparable electronic warfare systems and sensors, and with some stealth technologies of its own, this will make the J-11D an effective next-generation complement to the J-20 for decades to come. It is likely that the J-11D will integrate many similar enhancements to the original Su-27 airframe design as the Russian Su-35, including three-dimensional thrust vectoring engines recently tested on the J-10, a radar cross-section reducing frontal profile, an enlarged missile carrying capacity, and state-of-the-art electronic warfare systems. While the Su-35 was designed in the 2000s and relied heavily on technologies developed in the 1990s, the J-11D is set to be considerably more sophisticated and will very likely surpass the Russian flanker in its combat performance. The Chinese jet is expected to make more use of composite materials for a stronger but lighter airframe and is reportedly set to complement a pseudo-stealthy airframe with radar-absorbent coatings, which its Russian counterpart lacks. The most notable difference between the two designs, however, is that the j-11D will integrate a miniaturized active electronically scanned array (ESA) radar, a next-generation technology pioneered in its integration onto fighter aircraft by the Japanese F-2 and American F-22 in the early 2000s, and since integrated onto the PLA's J-20 and J-10C. Russia, for its part, has yet to integrate an ESA radar onto its frontline fighters. These radars will provide the j-11D with superior situational awareness to any other flanker variant, likely increasing its detection range by a factor of around 80% relative to the older j-11B. The name of the radar system to be integrated onto the j-11D is currently unknown, but ESA systems are considerably more difficult to jam than the pulse Doppler radars used by the original J-11 or the Su-35's passive electronically scanned array radar, while also minimizing the fighter's radar signature, making it more difficult to detect at range. The J-11D is set to integrate some of the most capable Russian military aviation technologies, which the country's increasingly cash-strapped defense sector has been increasingly willing to provide the Chinese PLA, while also benefiting from generous funding for indigenous research and development, which has led Chinese military aviation to surpass that of Russia in many key fields. The J-11D could potentially integrate a distributed aperture system, a cutting-edge technology currently deployed only by the J-20 and American F-35, which would further enhance its situational awareness, one which the Russian Air Force is unlikely to fund development of for its own flankers for the foreseeable future. China's new fighter will also deploy the PL-15 air-to-air missile, which are currently fielded by the PLA's J-20, J-16 and J-10C fighters, and retains a 150 km engagement range. This will provide it with a considerably longer air-to-air engagement range than both older J-11 variants, which rely on the indigenous PL-12, and Russian platforms, such as the Su-30 and Su-35, which have yet to integrate a next-generation air-to-air missile, instead relying on the R-77 and extended-range variants of the R-27. By integrating several next-generation technologies onto a tried-and-tested fourth-generation airframe design, the J-11D is likely to emerge as one of the most capable air superiority fighters in the world and the most capable flanker derivative in an air superiority role, likely quashing Russian hopes for further exports of the flanker design to China. How the aircraft will compare to Boeing's F-15X, an advanced fourth-generation air superiority platform currently on order for the US Air Force, which is in many ways conceptually similar to the J-11D, remains to be seen.